Determination of density of a solid. The objective of this laboratory experiment is to determine the density of a solid by using a spring balance and a measuring cylinder. To conduct the experiment, we will need a solid block of metal or a piece of stone, a measuring cylinder, a spring balance, some thread, a metal stand, and a beaker filled with water. Matter is anything that has mass and occupies space. The amount of matter in an object is called its mass. The SI unit of mass is kilogram or kg. The amount of space occupied by an object is its volume. The SI unit of volume is cubic meter or meter cube or milliliter or ml. If the mass and the volume of an object are known, then the density of it can be calculated. The density of an object is the mass per unit volume. If m is the mass of the given object and v the volume, then its density is given by the relation d equals m by v. The SI unit of density is kilogram per cubic meter or kilogram per meter cube. Listed here are the densities of some common substances. Density of water is 1000 kilogram per meter cube. Density of salt water is 1030 kilogram per meter cube. Density of ice is 920 kilogram per meter cube. Density of iron is 7800 kilogram per meter cube. Let's determine the density of a metallic block using a spring balance and a measuring cylinder. To determine the density of the given metallic block, we need to first measure the mass, m, and volume, v, of the metallic block. To measure the mass of the metallic block, take a spring balance and suspend it on the iron stand as shown. Note down the initial reading m1 of the spring balance in a table. Tie the thread around the metallic block and suspend it from the hook at the lower end of the spring balance. Note down the final reading m2 of the spring balance in the table. Repeat the experiment 3 or more times and note down the readings in a tabular form as shown here. Now, let's measure the volume of the metallic block. Take the graduated cylinder and pour some water into it. And note down the initial level of water in the cylinder. Take the reading V1 coinciding with the lower meniscus of water on the graduated cylinder and record your observation in a tabular form. Now, immerse the metallic block in water in the graduated cylinder. Observe that the level of water rises up in the cylinder. Note down the level of water V2 in the cylinder and record your observation in the table. Repeat the experiment 3 or more times and record your observations. Displayed here are the observation tables for mass m and volume v of the metallic block. Let's calculate the mean mass m of the readings taken during the experiment. Mean mass m is equal to the ratio of the sum of the individual masses to the number of observations. Mean mass m of the metallic block is equal to m1 plus m2 plus m3 plus m4 plus m5 divided by 5. By substituting the values of m1, m2, m3, m4 and m5 in the equation, we obtain the mass of metallic block, which is equal to 50 grams. Now let's calculate the mean volume V of the 5 readings of the level of water in the cylinder. Note that the volume of the metallic block is equal to the volume of water displaced by it in the cylinder. Mean volume of the metallic block V is equal to V1 plus V2 plus V3 plus V4 plus V5 divided by 5. Now calculate the density of the metallic block by the formula. Density of metallic block is equal to the ratio of the mass of the metallic block to its volume. Mass of metallic block is equal to 50 grams. Volume of metallic block is equal to 20 cubic centimeters. Substitute the values of mass and volume in the equation. The density of the metallic block is equal to 2.5 grams per cubic centimeter, which is equal to 2,500 kilograms per cubic meter, which is more than the density of water. Listed here are some precautions to be taken while conducting the experiment. Make sure that the indicator of the spring balance moves freely and it is at 0 before measuring the metallic block. Be sure that the metallic block is fully immersed in water. It should not touch the sides or base of the cylinder. Always note down the reading of lower meniscus of water.